So this is the last tension example problem in your notes. In this problem, you're going to use all the same skills that you used in the previous two examples. However, this time we're going to have to use some additional skills, and that skill is using a system of equations to solve the question. So you're going to have to solve two systems of equations simultaneously in order to answer this question correctly. And so in this question, we have two ropes that are at two angles, and they're supporting this mountain climber here that has a mass of 60 kilograms. And I want to find the mass I want to find the tension on both ropes that are supporting the mountain climber. Okay, so first thing we do, just like we've done for all the other problems, is write out a free body diagram for our system. So I represent my mountain climber as a point mass. My mountain climber has a weight, W, and the mountain climber's weight is supported by one rope pointing this way that acts at an angle of 35 degrees. And according to the problem, that's tension 1. And this direction, I have another rope supporting the mountain climber called tension 2. And this rope is acting at an angle of 48 degrees. Alright, and so first things first, we need to think about this in terms of two sets of equations. Equations in the vertical tension and force components, and horizontal. And as I said before, we're going to have to solve these simultaneously in order to answer this question. Okay, first things first, let's think about the components that we're dealing with. And so for the forces in the y direction, we know that there are vector components of tension. So this tension 1 has a vertical component of force that points straight up. Call that one T1y. And this T2 also has a vertical force component that points straight up. We'll call that T2y. Okay, and we know that according to this problem, and the fact that this point is in translational equilibrium, that all of these have to add together to equal 0. So weight is equal to W plus T1y plus T2y. Okay? And we know all of these add to 0 because they're in translational equilibrium. Okay? And so I can do a little more algebra. Negative weight is equal to T1y plus T2y. Okay, well, I'll stop there for a second. Do we know any more information about our vertical components? Well, we know that the weight is equal to mass times the acceleration of gravity, and we know that the weight of the mountain climber in this problem is 60 kilograms times negative 9.8 meters per second squared. Tells me that his weight is negative 588 newtons. So if I plug that into the weight down here, I see that he is 588 newtons. It's equal to T1y plus T2y. Okay, but I can't go any further because I have a lot of unknowns at this point. So what I'm going to do is I'm going to stop and I'm going to jump over to the horizontal and start looking at that. Okay, so I know that horizontally this point is being supported in two directions, and those two directions must be equal to each other. And so I have a x component of this tension vector so tension in the x direction from T1. I also have tension in the other x direction from T2. And I know that the magnitude of these two tensions has to equal each other because this point is in translational equilibrium. So I'm going to say that the magnitude of T1x is equal to T2x. I'm skipping over some steps and I'm saying magnitude because I don't want to have negative values. So I just am assuming that I'm going to compare the magnitudes in this case. Okay, so I know that I have T1x, and I know I have T2x, and I know I have T1y and T2y, but because I know neither tension, I'm going to have a lot of trouble solving this. And so what I'm going to do is I'm going to solve one of these equations and be able to substitute in what I solve that equation to into the other equation over here. So how does that going to look? So let's see. So for example, T1yx is equal to, what is T1yx equal to? Is equal to T1 sine, or sorry, not sine, T1 cosine 35. And I know that T2x is equal to T2 cosine 48. Okay, so let me give myself some more room here. Okay, so I substitute both of these into the equation above, and I get T1 cosine 35 is equal to T2 cosine 48. I'm going to solve for T2 in this case, so T1 cosine 35 divided by cosine 48 is equal to T2. Okay, so I don't know T1 or T2, but I do know how they're related by the ratio of cosine 35 over cosine 48. And so I can then come back to my vertical components over here. And so these aren't in terms of T1 or T2. These are in terms of T1's components and T2's components. So I can solve or substitute in T1 and T2. So I know that, for example, T1y is equal to T1 times the sine of 35. And I know T2y is equal to T2 times the cosine of 35. Okay, so I can substitute those in. Let me give myself some more room down here. So I know that 588 newtons is equal to T1 sine 35 plus T2. I'm sorry, that was a mistake. I shouldn't say cosine, I should have said sine. So make sure you fix that. Okay, so T2 sine 35. Oh man, I really messed up that one. I shouldn't have said sine at all. I should have said 48, sine 48. The angle for the tension on the line 2 is 48 degrees. Okay, and so I know what T2 is equal to, and so I can substitute this term here. I can substitute this term in here for T2. So I have 588 newtons is equal to T1 sine 35 plus T2 is substituted in for T1 cosine 35 divided by cosine 48 times sine 48. Okay, so I just substituted the whole equation in for that equation. Okay, this takes a lot of space. It's really satisfying once you finish solving these. Okay, so I'm going to factor out T1. So 588 is equal to T1 times sine 35 plus cosine 35 divided by cosine 48 times sine 48. Okay, this whole thing simplifies to T1. This whole term simplifies to 1.28, and I can solve for T1 at this point, and I get 459 newtons. All right, so I know tension 1. Now I need to solve for tension 2, and I don't have to go through such a complicated process like I just did, because I solved for what T1 was, how T1 was related to T2 up here. And so I can just simply take this equation that I started with down here and bring it down to here. And I can say that T1, which is 459 newtons, times the cosine of 35 divided by the cosine of 48 is equal to T2. Okay, and when I punch that into my calculator, I can solve for T2, and I get 561 newtons. Okay. I know that seemed really long, but it's just a lot of work. It's not too challenging, so do your best. All right, thanks.